Right. Okay. I thank David for being the guinea pig that tested out the system. I hope I managed to get this correct. Can I go forward and backwards? Yes. Okay. Yeah, this is about the Neptune database in its current version, NSB, which stands for Neptune Sandbox Berlin. And it's a database of deep sea marine microfossil occurrence data. And my co-authors, Joanne Renaudy and Pat Diver, did a lot of the programming and development, actually. And I've been acting in the last years more as a program manager. Okay, a little bit about the history of the database, a fairly detailed description of the current content, a little bit also about usage, including where I hope it's going to go in the future, and indeed talk a little bit about development plans and some of the ideas I have about networking and things like that. Okay, this is a complicated slide, and it's meant simply to show that it has a complex history. It started out as a project in the early 1990s at the ETH in Zurich. A whole group of micropaleontologists there worked on this, and it was inspired by the Sapkowski database at that time, and the goal was really to develop a tool for doing paleobiological research, particularly paleodiversity studies. And then after that project finished, it was eventually recast in the early 2000s as a modern internet database using modern software by a Kronos group that Cinzia Sarvato led, and Pat Diver did a lot of the programming for that, and Pat's here today. And then that project ended, and it's just a curation-only version that's still available at the Consortium for Ocean Leadership. But because it was slowly dying, that new version, I got some startup funding from CES in Oslo, and with Pat's help again, we brought it back online, and we've been working to make it more accessible and extend it in the last few years. Okay, the database consists of the occurrences of species in samples over time, and so it's a species-level database, not mostly a genus-level database, as, for example, PBDB is. And it also has the synonym lists and so forth, which have been vetted by community experts, including Jeremy, for example, and Brian Huber, who are both here. So the taxonomy at that level is pretty good, I hope. Whether the identifications are correct or not, that I can't say. And it has numerical age models, which I'll go into some more, and we've been adding geochronologic event data as well. And then there's, of course, a website we've developed, there's an age modeling program, and other things. Okay, this is the current content. There's nearly 800,000 occurrence records in the system at the moment, but almost all of it from really just 4 microfossil groups: the planktonic foraminifera, the calcareous nanofossils, coccoliths and stuff, diatoms and radiolarians. So it has a very, very small number of clades, but there's a lot of data per clade. There's like 315,000 records for the calcareous nanofossils. And it's mostly in the Cenozoic. There's some data, at least for the nanofossils and forams, in the Cretaceous, but remember this is a log scale, so there really isn't very much here for anything else. And in the Neogene, it goes up even an order of magnitude more. And so the data density, because it's such a small number of clades over a short period of time, is about 10 to 100 times higher than PBDB, but only for a tenth as many clades. So it's just a very more focused database. And of course, the distribution of data is global. We have 448 holes at the moment in the system, and this covers pretty well for the Neogene, all the biogeographic provinces for almost all the groups. It's somewhat with gaps in the Paleogene, depending on the fossil group, and there's only very limited geographic coverage in the Cretaceous. And it has, of course, as I said, the taxonomy, including the synonyms. There's nearly 19,000 names in the system, and it includes, as is typical for taxonomic data sets that have been vetted, only about a third of them actually are considered valid taxa. And then, of course, we have a lot of synonyms, particularly for the very, very productive revision workers in planktonic foraminifera. And then we have other things, and this includes things like questionable identifications and all sorts of other odds and ends, silicoflagellates that showed up in radiolarian slides, and so forth. But the database, of course, links all the data together and pulls back data also recorded under synonyms when you do searches. One of the distinguishing characteristics is that we use age models, not just named age intervals. And in theory, you can get 10 times to 100 times or even higher improvements in precision and accuracy for this type of age estimation. But it makes the assumption, which is very important, that sedimentation is fairly continuous. And that's okay for deep sea sediments for the most part. But you also have to have then a database that supports that, including section concepts. You have to have the actual numerical values for the locations, which is meters below seafloor for deep sea data. You have to have event data in order to be able to make age models. In this case, there are just two zonal boundaries here, those blue dots. And then eventually you wind up with an age model, that green line that relates continuously the depth to the geologic age. And we now have the event data in the system. This is something we added really just quite recently. And it's mostly biostratigraphic, but there's several thousand, magnetostratigraphic events as well. About 27,000 records are now in the system. And that's useful for evaluating the age models and improving them, as well as analyzing that data by itself. And of course, we have then this ability to make age models. And this is done by a new version of the age depth plotting program that's gone through several iterations. And it runs locally on a computer, but it links into the database system, so you can pull the data back out to make all this. All this data has been plotted up, directly being pulled down from the database. And then in theory, you can upload the age model back into the system. So you have the ability to maintain geochronology with this system. And it's a cross-platform thing, which runs more or less correctly on both Mac and PC, and we're still debugging some of the things on that. And this is an idea of age model quality. It's actually not all of the stuff in the system. I'm still evaluating the last 50 newer data sets, which are probably mostly going to be up in this range here, going from very poor to excellent. And it's a subjective estimate made by me, but it gives you an idea of the average quality, which is not so bad. And it's improved significantly in the last years as we've added new data into the system. Now, as far as the use goes, of course, the early version back in the early 90s was not internet capable, because we didn't really have much in the way of an internet back then. The technology for putting it on the internet wasn't really well developed, and there wasn't much use. It was an internal project. And then when Kronos put it online, usage picked up, and it's gone up to fairly high levels and started to drop back down again. And this is partially because the Kronos project was at an end, and the access to the system was becoming unstable. It wasn't really being maintained that well. And we're hoping, maybe this is a portent for the future now that we have it back online, that we'll start to see higher usage levels in the future through the new website. It's interesting that we only have about 20 or 30 papers where they really used it in a large, major way to do an analysis. And it's a mixture of journals that have done this. What's interesting is that in addition to the general purpose journals, you have some real hardcore biology journals like ecology letters, and equally hardcore earth science journals like Earth and Planetary Science letters, as well as, of course, paleontology and things like that. So it has a very broad range of people who are interested in using the data sets. But to be honest, because it has only about 1/10 as many papers so far as PBDB, the question is to why. Well, we've had less than 1/10 the funding, that might be one answer, but they have 387 people they list as people collaborating on PBDB, and we only have a half dozen for us. But the main reason is that paleobiology as such, which was the original goal of the database, is a fairly minor theme in marine micropaleontology, and that's because marine micropaleontologists are embedded in paleoceanography, and paleoceanographers really don't care much about this, okay? They control access to the funding. But the other thing is, until we've upgraded the chronology in just the last year or two, that most of the chronology in the system, and that's a mainstream sort of type of information that paleoceanographers would be willing to support, that stuff went back to the early 1990s, and it wasn't really much of interest to them. So we're hoping that we'll have a better chance at developing the system in the future by strengthening that aspect of the database into the future. And so we have a wish list, and of course, all the usual things, improving the data content and particularly flagging errors, that sort of thing, which we are working on. And as I say, we want to improve the geochronology, and one thing we really probably need to do is add up-to-date concepts for doing geochronology research, which includes composite sections and a lot of things, orbital tuning tools and things like that. And then, and I'm not going to talk about all this other neat stuff that we theoretically could do, but talk about networking a little bit. And this is my marine micropaleontology-centric view of what we're doing in paleontology these days for databasing and managing our data sets. This is the simplified version of the figure. I had a more complicated one originally. And we have, for the deep sea data, we have the Neptune in current form NSB. For all the things that occur on continental crust, that's the way I look at these sort of things. You have all these other databases like PBDB, Neotoma, and more recently the Biodiversity Database. We have lots of data in archives, and we have all sorts of taxonomic databases. We have things like IODP's own databases, And it's not very well integrated, for one thing. There's not a lot of networking going on. I've thrown in a few links where I know they exist. We're working on developing some new links. I just saw the first prototype this morning when I got up between Biodiversity and NSB. But for the most part, things aren't really talking to each other, and we don't even have data standards which are important in the field in order to network data together. And then we also have some problem children, particularly who's taking care of the age information for individual sections. Almost no one is. And yet, without that, we can't really place our data into a scientifically meaningful context. So there was a recent call from the Wissenschaftliche Literatur Versorgungs- und Informationssystem division of the DFG, and that I refer to for obvious reasons as LIS. It was for cross-disciplinary networking. So we put in a proposal, and it's a proposal which probably has, 10% chance of being funded, which would give us the chance to link some of these types of data together, modern distributions and oceanographic data, the archives like Pangea and NGDC, the community catalogs, and use the fact that NSB has within it the key cross-linking information that would allow us to put all this data together. So this is sort of one direction in which we'd like to go, and this would give us a nice platform for not only doing the improved research with those linked data sets, it'd be a good platform for future expansion as well. The problem, of course, is you have unavoidably then added a substantial layer of complexity, and you need skills to set this sort of up and maintain it, and so you become more dependent upon future funding, because if it gets to this point, neither Joanne or I are probably going to want to do all the software ourselves. We'll have to have some long-term support. And our museum, at least, is committed to maintaining the baseline support for such a system, because it's now part of the Bio project in Germany, which is this large initiative, stands for the German Federation for Biological or Biodiversity Data Maintenance, to provide these sort of infrastructures over the long term. And Robert Huber was supposed to be talking about this, but I understand is not going to make it. Anyway, Germany is finally stepping up to the bat and starting to get serious about this, and our museum is part of that, so we hope that we'll be able to embed all of this in that sort of infrastructure in the future. So to summarize, how am I on time, by the way? It's 5 minutes. Okay, good. NSB is the current version of the deep sea planktonic microfossil database, and it includes the taxonomy, the synonyms and so forth, so we can work with data sets that to some degree have been cleaned up taxonomically, though we can't go back and check the individual identifications for 769,000 records. It's very useful for paleobiology. It was originally designed for, and taxonomy, of course, and we are working very hard to make it into a useful tool for paleoceanography research. It's been moderately successful. I mean, we've had our share of Science, Nature, but not sort of papers, but it's been fairly modest in comparison to some of the other databases, but we're hoping by expanding to reach communities like the paleoceanographic community, and because we now have a newly accessible website, that it should improve in the future. And there's a lot of stuff that can be done, but we're taking an opportunity to call for proposals, which is the first time I've seen in 20 years in Germany an opportunity to fund something like this also. So I'm definitely going for it. And anyone who wants to use it, just ask us and we'll give you an account so you can use the system. And you can access it through the website, or if you have a real need, just directly through SQL, if you'd like to do it that way. Okay, and then last but not least, thank you for listening. Thanks for the invitation to come and give the talk. And I haven't listed everybody, but these are at least some of the people who over the years have helped out in developing the system. So thank you. A few minutes for questions, if anybody would like to. Yeah.
You had a couple of times up there an age model.
Yeah.
What do you flesh that out a little bit? What you have in mind?
Okay. Let's see, that's the back.
Not for specifically for the deep sea, but sort of the linking across the databases on the continental and deep sea records.
How that works. Well, what's important, I'll go back here, okay.
There we go.
Most of the data in Pangea or NGDC that's for this deep sea type occurrence data is linked to the same set of sections. But in these databases, you simply have that this sample, we had oxygen isotope measurements of the following sort. And there's no information about the age. And we are able to provide precise age estimates for all that data. And there's probably millions of records of stuff in these two databases that are linked via the sample information into the age model. So that's the primary concept right here.
So is there an opportunity to update, say, the age models and the information when you have the post-cruise publications from Electrovision?
Yeah. This is what we're trying to set up just right now. We have this, other way. Whoops, I went the wrong way. Age modeling program, which I'm sure you already saw, that sort of thing. And the idea is that this will allow you to upload a new age model into the system if you're running this program and you have authorization access. And one of the things that Pat and Brian, if you want to come, and Joanne and I want to talk about at this meeting is how best to go about doing that, because we of course don't just want everyone to download and start doing age models at random. We want to have some quality control, and so only certain people should be authorized to do this. But whether we want to put it into a temporary file and then add more metadata onto the age model before we get it uploaded, or build in additional tools to add more metadata during the development process right here to the program, we haven't decided yet. At the moment, give us the age model and we'll load it for you. That's not a problem. But right now we don't have it fully automated, but we're working on it.
Anything else? All right, thanks very much.
Okay.
Next up is Jeremy Young and